Hey, second bell, it's Mrs. Pope. Oh, there's the bell. I know we ran short on time doing these graphs, so you do have to complete 11 through 22 for homework, but I wanted to do two more for you just so that you had a little more understanding, just for those of you that need a little more help. So I am expecting all of these to be done on Monday, and I can tell you right now I'm going to collect the homework, so make sure you complete them all. Okay, so I'm going to graph numbers 14, 18, and 21. These are ones that I was going to graph in class if we had time. So 14 is f of x is equal to 6 over x minus 5. Okay, so the first thing, if I want to find the x asymptote, then I look at set the denominator equal to 0. Well, that's actually just x, so my x asymptote is x equals 0. Now here's where we start talking about the y asymptote. So I'm talking about the y asymptote. I'm talking about where is the function. Remember, f of x is no different than y. I could have written this as y equals 6 over x minus 5. Same thing, doesn't mean any difference. So I'm trying to say, where is this function, where is y headed as x goes to infinity? So as x gets bigger and bigger and bigger and bigger and bigger and bigger and bigger, if I take 6 and divide it by that, it's going to get smaller and smaller and smaller and smaller and smaller. So if you think of, if you have $6 and you're going to divide that by 2 people, okay, at least everybody's going to get $3, not bad. If I start to divide that by 6 people, okay, now we only get $1. If I divide that by like 10 people, anything over 6, we're going to have less than $1. If I only have $6 and I need to divide that by 1,000,000 people, then you're really not going to get anything. It's as close to 0 as you can get. So think of this as if x were 1,000,000, what's going to happen to the entire function? So this part of it, this fraction right here, this is going to go towards 0. But I'm looking at the y asymptote, the whole function. So if this is going towards 0, I could just replace that with 0. 0 minus 5, that means my y function is going to be going toward negative 5. So now you should be able to use those, sketch your asymptotes. The x, if I have x is equal to 0, that's just going to be on the y-axis because that's where x is 0. And then y is negative 5. So that's those are my boundary lines. And now we're just going to find, doesn't matter, x is to the left of 0, x is to the y of 0, and just make a little table. So you can pick any numbers, doesn't matter. I'm putting negative 1, negative 2, negative 6. I just like ones that might turn out nice. So negative 1, 6 divided by negative 1 will be negative 6. Take away 5, you'd have negative 11. Negative 2 should be negative 8. Negative 6 should be negative 4. Negative 6 divided by negative 6 would be 1 minus, yeah, just check my math. Negative 3, yeah. Okay, so then plot these points. Negative 1, negative 11, that's way down here. I should have made this a little longer. Goes at 5, 6, 7, 8, 9, 10, 11. You have graph paper, so yours will be a little better. Negative 2, negative 8, somewhere around there. Negative 6, negative 4. Make yours, wait, does that say negative 1, 2, 3, 4, 5, 6? Negative 4. Something is looking fishy here. What happened there? Did I do something wrong? Negative 1 would be negative 6 minus 5 would be negative 11. Negative 2 will be negative 3 minus 5. And then if I put in negative 6, I would get negative 1 minus 5. Oh, that's why. Negative 1 minus 5 is not negative 4, it's negative 6. Hopefully somebody caught that earlier. You see where I said that? Then that's a good point. You should think to yourself, wait a minute, how am I ending up above this boundary line? Something's going to be wrong. I should have had negative 6. Negative 6. So let's say that's negative 6. Go down here, and that's negative 5, so that'd be about negative 6. And there's my hyperbola. So that was a good mistake. I like that one. Because then you can see why I stopped. I'm not going to just go ahead and put that there because then it would cross the asymptote. And then you can pick the same numbers or different numbers on the right. Doesn't matter. Just pick some x's and y's. 2, 3, 6. You'd have negative 2, negative 3, negative 4. So then if you graph these, 2, negative 2, 2, negative 2, 3, negative 3, and 6, 6, negative 4. So you can see that it's going to look like that, something like that. Okay, so there's that. Let's do 2 more quickly. If you need to pause or rewind, feel free to. I can't remember the other one I said I was going to do. I did 21 in class already. I know that was at the end. So here's another one that's kind of similar to it. 3 over x minus 7 minus 8. So this is the function. So my x asymptote would be, this is a 7, x is equal to 7 because that's what would make the denominator equal to 0. My y asymptote is going to be y is equal to negative 8 because this would go towards 0, I'd take away 8. You'll notice the pattern here that once it's in standard form, this is always going to be the y-intercept. I'm not going to find the points on this one again. You can do that on your own. Clearly I messed up on the last one. So plot x, the asymptote x is 7. 1, 2, 3, 4, 5, 6, 7. And y is negative 8. And then make your 2 little tables, x, y, something to the left of 7. So you want to have like 4, 5, 6, I don't know. And then something to the right. Those points aren't very important. They're important, but you can choose whatever you want. Something to the right of 7, 8, 9, 10. Or if you want numbers that are nice, a little more friendly, and they won't end up with decimals or fractions, then feel free. Okay, you should have had 21 down. It's the same idea. I'll do it again one more time, but not all the way out. F of x is equal to negative 6 over x plus 4 minus 2. So the x asymptote was x equals negative 4, because that's what would make the denominator 0. And the y asymptote, y is equal to negative 2. Sketch those. Y is equal to negative 2. And then you're going to make your tables and draw in your hyperbola. Hope this helped a little bit, and make sure you have all of this done on Monday. Thanks. Have a great weekend. Bye-bye.